Good morning, children. Today we are going to Physics chapter 13, Sound, the continuation. In the last class, we saw how the sound is produced and how it is received. In the human ear, how the sound waves travel and reach the brain through the hearing nerves, auditory nerves, and the sense of hearing. All those things were discussed, right? So today we are going to see some properties of sound. We know that the sound travels as a wave and it is a mechanical wave, right? Moving in the longitudinal direction. So this is a wave. Like how we say it as an oscillation in a pendulum. When a pendulum bob moves from one end to the other, the to and fro motion causes an oscillation. The sound is produced by the vibration of the particles, right? So when there is a vibration, it causes an oscillation of the wave. I can better tell it as oscillation or vibration. A wave will have a crest and a trough. Okay, so this, if you see here, you could, the first half, that is in the top portion, it's like a mountain and the bottom is like a valley. So one mountain and one valley will be one wave or an oscillation of a wave. Okay, so the peak point means the highest point. The highest point of the mountain is nothing but the peak or the crest. Okay, similarly in the valley, the highest point, the deepest point is your trough. So that is why how do I describe an oscillation of a wave is when one crest and one trough is completed, then it constitutes to one oscillation of a wave. Okay, so the peak of the mountain is your crest and the peak of the the peak of the valley is your trough. One crest and one trough is one oscillation. Look at this. 1, then the next oscillation 2, then the third oscillation 3. Okay, so this is a wave of 3 oscillations, right? So one crest and one valley will be one oscillation. Now always a wave which is a longitudinal wave will have the time and displacement. As the wave travels, its x-axis will be in terms of time measured in seconds. The y-axis will be your displacement. What is meant by displacement? The differences in the position. The displacement is nothing but with respect to the center middle line, what is the deviation of the wave from the center? That is what the displacement. We have learnt already in the motion chapter that the displacement means the distance traveled, right? The same thing. How a wave is deviated from its center position. That accounts for the displacement in the y-axis, and in the x-axis you will have the measurement of time in seconds. Okay, so this is the basic thing you should know about a wave. So the first property we are going to discuss in sound is amplitude. What is meant by amplitude of sound? Amplitude is nothing but the maximum displacement of a wave from its center position. Okay, so in this wave, from the center, what is the maximum displacement is your amplitude. Now consider an example. Consider the waves drawn here. This is also a wave and this is also a wave. But if you see here, the maximum displacement, that is the amplitude of this wave from its center position, is high, right? In this wave. Whereas look at this, here the displacement is less. So I can tell this as a high amplitude wave and this as a low amplitude wave because of the displacement from its center position. Understood? And the next property we are going to discuss is frequency. What is meant by frequency? Number of oscillations per second. We already saw that what is meant by an oscillation. One crest and one trough will constitute for an oscillation. So this is one oscillation. Okay, but for calculating frequency, you should know how many such oscillations have traveled for a period of 1 second. Okay, so here this constitutes one oscillation in the sense for a time period of 1 second, very minute period only, for a time period of 1 second, how much oscillations are traveled. That gives your frequency. Okay, you know that the sound waves travel very fast within a fraction of second. That is why all the waves, whatever I'm talking is heard to you without any time lapse. So imagine how fast the sound waves are traveling. Okay, so when I calculate for a very small time period of 1 second, the number of oscillations traveled will give my frequency. So look at this, 1, 2, 3, 4, 5 oscillations are completed here. So this is having a frequency of 5. It is usually will be in the range of 50, 100, 1000 waves only, but I have drawn only few waves in my notebook. I cannot draw huge waves, right? And in this case, how many waves are there? 1 and 2. So for a time period of 1 second, it is, the frequency here is 2. I will always give the unit of frequency as hertz, denoted by the letter capital H, small z. Hertz is the name of the person who found about frequency of sound. Okay, so the unit of frequency is hertz. I will always call the frequency with its unit. In this case, it is 5 hertz. In this case, the frequency is 2 hertz. Okay. Now, the normal human hearing range, that is the audible sound for the human ears, is 20 hertz to 20,000 hertz. If somebody whispers in our ears, we are able to hear. If any huge noise made by the horning of vehicles, flying of aeroplane, all the sounds are also able to hear. But only few range, the range in which the sound can be heard by the human beings is the audible range, that lies between 20 hertz to 20,000 hertz. I can write this 20,000 as 20k. K means kilo. So kilo means 3 zeros, right? So 20,000. The other way of writing 20,000 hertz is 20 kilohertz. So this is the audible range of human ears. Below 20,000 hertz also you cannot hear. Above 20,000 hertz also you cannot hear. Any sound between 20 to 20,000 hertz only is heard by the human ears. This is the audible range of hearing. This frequency level only the human beings can hear. So, if any sound less than 20,000 hertz or more than less than 20 hertz and more than 20,000 hertz is inaudible sound. Inaudible means cannot be heard by the human ear. I call the sound less than 20 hertz as infrasound, and More than 20,000 hertz means it is ultrasound. Okay, the next property we are going to discuss is loudness. Loudness depends on the amplitude. Okay, so loudness is directly proportional to the square of amplitude. That is the twice of amplitude is your loudness. We know what is amplitude, right? Amplitude is the maximum displacement of the wave from its center position. Now, the square of amplitude is your loudness, means this is the wave having a displacement. So how could the loudness be? Means this is amplitude of a maximum displacement, its square. Okay, so when I have the displacement twice means then it is my loudness. The unit of loudness is decibel, written denoted as small d and capital B. For breathing, the loudness is 10 decibel. For whispering, it is 30 decibel. And in a busy traffic, the loudness can be of 70 decibel. Okay, so the loudness purely depends on amplitude only. If the amplitude is twice, let us write it as 2a. What could be the loudness? You have to square it. So the loudness will be 4a square. For just simple understanding, I am writing. If the amplitude is halved, what could be the loudness? If I square, it will become as a square by 4. So the loudness depends on your amplitude only. If the amplitude increases, the loudness also increases because they share the direct proportionality. If the amplitude decreases, the loudness also decreases. Then the next property is pitch. Pitch or shrillness. It will determine how the sound is, whether it is a feeble one or it is of a high pitched sound. This is directly proportional to frequency. Okay, so the frequency is the number of oscillations per second, which we already know. If the frequency is high, your pitch is high because they share a direct proportionality. If I hear a sound of a frequency 50 Hz, then the pitch is also high pitched. If I hear a sound of 5 Hz, which is a small value, then the pitch is low. If frequency increases, pitch also increases. If frequency decreases, pitch also decreases. Then the next property is time period. You have already learned the time period of a pendulum. That is the number of oscillations per taken to complete one oscillation, right? So the total time by number of oscillations, that is the formula for time period. Now we already know that the frequency is the number of oscillations per second, right? So the time period and frequency will share an inverse relation. What is the formula for frequency? Number of oscillations per second. For 1 second, the number of oscillations only is your frequency. So this second goes to the numerator, and that is what we have written here as total time by number of oscillation is a formula for time period. That is nothing but the inverse of frequency. Don't confuse with the time period and the frequency relation. Okay, we know that already. Time period means the number of for a period of time period means the time taken to complete one oscillation, right? So we know that this is only one oscillation. What is the time taken to complete? That is what we call by the name time period. Understood, children? So total time divided by number of oscillations will give me the time taken to complete one oscillation. That I am writing it the other way as it is the inverse of frequency. Okay. Now, we know that loudness depends on amplitude and pitch depends on frequency. If I tell a drum produces sound in a low frequency means, then what is its pitch? Is it high or low? Low frequency means low pitch. The bird produces sound in a high pitch. Then its frequency is high. Okay, we could hear the lion's roaring sound. It is to a much extent, to a more distance, because it has high loudness and low pitch. Okay, the sound of a bird is having high pitch but low loudness. So in all these examples, we come to understand that if the frequency is high, pitch is high. If the amplitude is high, loudness is high. Okay, so this 4 properties, loudness, amplitude, pitch and frequency, are necessary to be known for the sound. But when you compare the loudness and pitch, they both are inverse. If the loudness is high, pitch is low. That example is only roaring of lion. The roaring of lion can be heard to a much different distances. So its loudness is high, but whereas the pitch is low. The bird sound has high pitch and it is somewhat feeble. Feeble means a very soft sound, but its loudness is low. Okay, so these are the 4 properties of the sound. If you have any doubt in this session or if something is confusing, kindly contact me. Thank you, children.